Episode 180 of CppCast with guest Pablo Santos, recorded December 18th, 2018. Today's sponsor of CppCast is PVS Studio. PVS Studio is a tool for bug detection in the source code of programs written in C, C++, and C#. PVS Studio team will also release a version that supports analysis of programs written in Java. And by JetBrains, maker of intelligent development tools to simplify your challenging tasks and automate the routine ones. JetBrains is offering a 25% discount for an individual license on the C++ tool of your choice, CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CppCast during checkout at jetbrains.com. In this episode, we discuss cross-platform mobile frameworks and SG20. Then we talk to Pablo Santos from Codice Software. Pablo talks to us about Semantic Merge, Plastic SCM, and more. Welcome to episode 180 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
Good. How you doing, Rob?
Doing pretty good. 180. We're starting to get awful close to 200. We'll hit that in like 2 or 3 months into the new year, right?
Yeah, 20 weeks, something like that.
4 or 5 months. I don't know.
5 months, yeah.
Right but it won't take too long.
Right. Yeah, pretty crazy.
All ready for the holiday season?
I am ready to not be traveling for a time. I just got back from Hamburg, and I will be not traveling again until Folkestone, until C++ on C. Okay. Which, by the way, if I might say, you're running out of time to buy tickets to my class there, so if you were thinking about it, go ahead and do it now.
That's right. This is on C, which is in February, right?
It's in February, first week of February, in Folkestone, England, and I'm giving a class on ConstExpr. Okay. And it will apply to anyone who's using C++ 11 or forward. C++ 11, ConstExpr is a little bit harder, but we'll talk about what their limitations are.
Sounds great. At the top of the episode, I'd like to read a piece of feedback. 2 weeks ago, Jens from Meeting C++ put out this survey asking on what speed you listen to CppCast. And the results of the survey, he put out the options 0.5, which I thought was ludicrous, and kind of forgot that was even an option that we have on the website to listen to the podcast at 0.5 speed. 1x, 1.25x, or 1.5 or 2x. And the vast majority of the poll answers said 1x speed, 62%. But a couple of people did put down the 0.5, which really fascinates me. I would never imagine listening to a podcast at half speed.
Well, it's kind of funny because I don't know if our listeners have noticed, but it has happened a couple of times that your recording has gotten out of sync a little bit, and you start to sound kind of like you're speaking at half speed.
I think I've always done a pretty good job of editing that, so I doubt they've ever heard that. Maybe one episode it came out. I don't remember, though.
Next time it happens, I won't tell you so that it doesn't. But I've had plenty of people actually tell me, like students and whatever, like, you sound different in person. Oh, right, you're not talking as fast as I expect you to. Because they watch all of the talks.
1.5.
Yeah, CppCast and my YouTube channel.
Okay. Well, we'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Pablo Santos. Prior to entering startup mode to launch Plastic SCM back in 2005, Pablo worked as an R&D engineer in fleet control software development and later digital television software stack. Then he moved to a project management position, leading the evolution of an ERP software package for industrial companies. During these years, he became an expert in version control and software configuration management, working as a consultant and participating in several events as a speaker. Pablo founded Codice Software in 2005, and since then is focused on his role as chief engineering, designing and developing Plastic SCM and Semantic Merge, among other SCM products. Pablo, welcome to the show.
Hello, thank you for hosting me.
I'm curious about this fleet management that you were working on. Can you tell us something about that project?
Well, it was actually a C++ project, and it was my first job once I got out of the university. And it was, a piece of software to actually show information about the buses going through the city. So in every bus stop, you have information about the next one and so on. And then specifically the part I was working on was the control center for that, like the entire software that the guys had in the control center to actually monitor if there were delays or something was wrong or something like that. The GPS at the time, it was around 2001. Were not, not that we're not that precise, but probably they were not so available that they are today. So we had to do a lot of corrections in things like, interpolating the position, stuff like that, because you couldn't trust the device all the time. So it had a mix of things, like from socket level sending messages to actually low level stuff to DirectX rendering things and graphics, which was my favorite part, by the way. And so, yeah, a lot of things. And my first experience with version control too.
That sounds pretty awesome, actually. I don't know if I've ever been to a city in America that had bus stops that well organized that said what the next bus was coming and how far away it was. Have you ever seen that, Rob? I've seen it in Germany. So. Yeah, that's pretty neat. I never really thought about what's behind that to actually tell you the real truth of what's happening.
Yeah, it was something, today here in Europe, I will say it's sort of everywhere. Right. But that time when I joined was sort of new. There were just a few cities adopting that. But yeah, now it's something like you sort of expect, right? You get to a bus stop and then you get this digital information. Years ago when I was a kid, it was just like, something printed down there. So you have to make your calculation when the next one's going to come or something. But yeah, that's good. And I think right now they even have an app. I don't use it that often anymore, but I think they even have an app. And the nice thing is they can even reuse the whole thing for other uses, like, police and stuff like that, where the cars are and things like that, all for control centers and so on. So yeah, that was pretty exciting.
Well, yeah. Well, we're going to talk more about source control in a minute, but can you give us a preview and tell us maybe what source control you used then?
Of course, my first version control then was source safe, nothing super fancy.
Yes.
That was probably the motivation why I started thinking I have to create something better.
To be fair, SourceSafe was kind of terrible. I don't think it's maintained by Microsoft anymore. But if you had a team of like 2 people, it was a cheap and easy way to set things up. But
yeah, it's better than nothing. By that time, right now every new student they learn Git not Subversion anymore, probably Git and at the university or college and so on. So they get this understanding. But 20 years ago, you didn't have that information where you were at the university. So you saw SourceSafe was kind of cool. And well, I started to hate it when I started using it, but now in my memories it's kind of cool because as bad as it was, it created a lot of conversation after that. So it's really, you meet any developer around the world and you can spend quite a good time talking about how bad it was. So it's kind of just kind of social, right?
Yeah, and as you said, it's better than nothing. At least it gave you an introduction to, not copy-paste file management.
Yeah. Absolutely. This nightmare of this is the good one .zip, good one really good .zip. This is the one, the final. Yeah.
Oh yeah. That's terrible.
Okay, so Pablo, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about SCM and merge control tools and the other stuff that you work on. Okay.
Okay. Perfect.
Okay, so this first one is Bowden Cross-Platform Framework, and this is a preview release that they have up on GitHub. And it looks pretty cool. It's made for Android and iOS applications. If you want to make an Android or iOS app and you do so in completely, native C++ without having to do any Objective-C or Java, then this is a good solution for you. I think what makes it different from Qt controls is that where Qt, it's like you're rendering everything in Qt's own widgets. This is kind of creating a wrapper, but then doing the actual rendering of like a button with the actual iOS button control. Or the Android button control.
It's very much in that vein like WX widgets, which I don't know if we've ever discussed that on this program. Have we?
Definitely not in any depth.
Okay. But yeah, WX is the same idea. It's always native controls, which has its limitations because you're limited to what is the union of all the things that are possible with native controls on those platforms.
Is WX widgets does that do mobile, or is it just like a desktop framework?
I'm going to have to look to see if it was ever updated to add mobile, because mobile wasn't a thing when I last used WX widgets.
So to be fair, kind of like a WX widgets for mobile.
Yeah, it might be. Well.
Okay, well, just a small comment. I'm more on C# these days than C++, but I find this news really exciting because this is one of the things we really miss on the C# landscape. There are many options, but not really a single one for all platforms. So like a Qt for everything, right? So and if this one can make the cut, probably we can have nice wrappers too. So kind of excited about it.
Well, and since you're talking about C#, I mean, this is also kind of similar to what Xamarin Forms does, I think, right?
Yeah, exactly. But the thing is that they are bigger on the mobile side of things, not that much on the desktop side of things. I'm personally more interested on desktop because of the kind of tools we develop.
Right.
But they are really focused on is that they can also work on desktop, but it's not the thing they do, right? It's like a secondary thing, so.
Right. Jason, did you find out with whether WX Widgets has mobile support or not?
I see no mobile operating systems listed.
Yeah. Okay, so the next article we have is this is from Christabella, and it's SG20 Education and Recommended Videos for Teaching C++. And I think we probably talked a little bit about this new study group when we were talking to Ashley and JF about the San Diego ISO C++ meetings. And this new group is just going to be focusing on education. So Christabella and JC Van Winkle are the ones who are heading the group. And I thought this was a really interesting article talking about kind of how this group got started. And he also has a list of several recorded talks that I thought was a really nice curated list of good CppCon and meeting C++ and etc. talks that are all worth watching.
Yeah, there's definitely a lot in there.
Yeah.
And several of them I have not watched and should probably go back and watch at some point.
Yeah, there's always plenty of talks I need to catch up on. I'll also look through these. Do you have ever had any interaction with the ISO C++ committee, Pablo?
Not really. I try to follow where they are going and so on, and I really miss this part of having the a roadmap of what they are going to do and so on. That I think that's something we missed for a long time, right?
Yeah, there's certainly a lot more forthcoming with the direction of the committee and everything these days, it seems. Okay, and then the last thing we have to discuss is C++ Now call for submissions is now live. The conference this year or next year is going to be May 5th to May 10th. And what is the deadline to get your submission in?
It's relatively soon, I think.
Yes,
January 23rd.
January 23rd, and then proposal decisions will be sent out February 25th. Yeah. And the program goes online in March. Are you working on your talk submission yet, Jason?
Nope.
You planning on one, though?
Let's say probably.
Okay.
And I say probably because there's a lot of conferences this year, right?
Yeah.
And I am hoping to go to Core C++, which is in Tel Aviv, the week after this.
Right.
So that complicates my schedule. And so no firm decisions from my part have been made. I'll probably submit something and see what happens, what gets accepted, whatever. And C++ now is always easy for me to get to because I just have to drive across the Rocky Mountains. Yeah. Much easier than it would have been 150 years ago, anyhow.
Okay. So, Pablo, to start off, why don't you tell us a little bit about Semantic Merge?
Okay, so, well, as you said at the beginning, we started developing our own version control system, like we wanted to come up with a product, and soon after, we had to develop one of the pieces that you need to provide in a version control, which is a merge tool, right? You get two branches, you want to merge them, you go to the file level, and then you have to get, like the two contributors and a common ancestor and merge them together and all that, right? And then we started thinking, is there a better way to do this? We developed the entire algorithm for the text-based diff and merge, so that's something we did, and we continue developing and improving over the years. But then we said, okay, what every single programmer you talk to has in mind is something like, okay, why your diff and merge tool doesn't understand the code? Why it works on a text-based instead of on a, method-based or function-based? And that's exactly what we wanted to do, right? At the very beginning, and I remember drawing the first, blueprints or the first ideas, I will say, really soon after just founding the company and starting up. But it had to pass a lot of time since we really had the basics and enough technology and enough of the, different things you need for the core to actually start thinking on it, right? And then it was around 2012 or something like that when we really started working on it. And basically what we did is, okay, let's parse the code and then let's calculate the diff and the merge based on the code structure, not the actual positions of lines and text blocks and so on, right? And that's basically it, right? I mean, once you describe that to a developer, he immediately imagines what the thing is about, right? So if you go and move a method to a different location, a function to a different location, and then someone else modifies it on the original location, and then you merge it, you get the move and the changes put into the right location, right? And that's the magic of the semantic thing, right? That's basically one of the things that at the end of the day, we rerun a lot of merges. We have something called a replay, and we replay public repos on GitHub and try to repeat all the merges to figure out how we can do better and so on. And at the end of the day, even if some teams try to avoid like refactoring because, for them it's not a good idea to actually be refactoring code while it's live evolving, let's say, right? While it's still evolving. They prefer to do like a freeze or something like that, but they try to avoid it. But even though it happens, right? And there's a good percentage of conflicts that we consider semantic because they involve moved pieces of code. And that's a little bit what semantic is about, right?
So, what languages does semantic merge work with? Because I'm thinking about the fact that you have to parse these.
Absolutely. The downside of this approach, I mean, and we support both, right? We have tools to actually, and in fact, Semantic provides a regular text-based diff tool, our merge tool, right? Like KDiff3 or any other. So it does that. I mean, it does this basic. But then, if it has support for the language, it does more because then it understands the structure and so on. We can even plug external parsers and all that. But to your question, we support C++, and we also support C. We support Java, C#, and we also have some external parsers. I mean, not developed by us, but actually by the community for Delphi, the object Pascal from Portland. And also we have something for Python and a little bit of we have an experimental one for JavaScript and things like that, right? I mean, it's not difficult to add more languages. In fact, we are working on Swift at this point, so it's not difficult to add more languages. And most of the time were based on a standard parser. I mean, for instance, if I can tell you a little bit of the story for C#, it's very easy because we have this Roslyn project by Microsoft where they provide the entire compiler, infrastructure, and parsing and everything. So it's very simple to get the AST. So that's sort of simple. For C, we use libclang. I don't know if my pronunciation is correct for that. That's clang or
everyone says it differently. Yeah.
Okay, so that's fine. And that's the strategy we tried for C++ at the beginning. But C++ is by far the most complex of all of them. So it was kind of, okay, should we go that direction? It's going to be crazy. And it was a little bit crazy with libclang because you need to apply it, or at least our understanding was that you need to give it all the not dependencies, all the includes. So it made it like a little bit of a nightmare because you're just merging a file, so you get the other two files, and you don't want to configure your merge tool to know all your include paths and stuff like that. But at the end of the day, we got a very nice parser from the folks at the Eclipse CDT project, right? They have a library to actually parse C++, which is what they use for their IDE in the Eclipse project, and we use that. So actually we parse C++ using Java, which is probably like a little bit of a sin, but it works pretty well because it's sort of very independent, right? It's not like, you have to feed it. If you need to ask the user to actually configure his merge tool almost like a make file, he's not going to use it, right? This is going to be, okay, you're crazy, right? So now you need zero configurations, like, okay, it's there. You just use it and it goes, and it's fine. At the end of the day, we don't need super strict parsing either. It's more like, okay, where are the functions? Where this start? With this end? Where this ends? If this, it's all what we need. We could even probably have gone the, pairing brackets and stuff like that, but, it's never that simple with C++.
So I'm just trying to imagine how all this comes together. You've got a parser that builds some sort of AST or semantic information about the code, and then do you actually diff then the ASTs effectively?
Exactly. That's the trick, right? Since we develop our own version control system, Plastic SCM actually, which is like an alternative to Git. So since we develop all that and all the algorithms inside, we actually reuse part of the code. We have to actually merge directories and the elements of directories, which are you have trees there. So we sort of reuse the same, actually not the same code, but the same know-how and the same, and some of the tests too, to be honest. We reuse that to actually put it into the file. So it was like, okay, you are merging at the directory level, and then you zooming into the file level, but you split it into components. So you have a namespace, and then inside the namespace you have a class, and then you have functions. And well, depending on the language, there's a different construction. If you are doing Java, it's a little bit different than C# or C++, but at the end of the day, it's more or less the same, right? What we don't do, we stop at the method level. So if you move a method to a different location, we need to identify whether it's the same method. So basically we parse the ASTs, we diff the ASTs, and then we need to figure out if something you move and rename is still the same thing. And there we use some similarity algorithms to actually find if the text blocks inside are similar enough. Something that is worth saying is that in order to cut complexity, because the problem can get super complex, right? What we did was, okay, we parse just up to the declaration level. So inside the function itself, we don't parse. The parsers actually do its job, but we don't use that, right? It's like, okay, I know there is a function, and then you have 50 lines. Okay, these 50 lines are text for me. I know it was moved to a different location. I know it was renamed. But then we don't merge at the level of ifs and else and stuff like that, right? That's what I mean. It's more at the method level. At the end of the day, you get it merged, of course, but we use regular text for that because otherwise the complexity explodes, almost unsolvable thing, right? So yes, we create the ASTs, we take the ASTs, we diff them, we get two pairs of differences, basically how it was with your version, how it was plus your version, and then that's what we use to calculate the actual merge. And the super nice thing is that it's amazing the number of manual conflicts that are a nightmare to solve that become even automatic, right? Like you move a method to a different location, then you change it, you try to merge that with a regular merge tool, and you get, the old method that has nothing to do, that is now in the top of the function or of the file or something, try to be matched with another method that has nothing to do with it, and you go crazy. Then as soon as you go in semantic mode, okay, it knows the same method. It doesn't matter what it is, right? It just knows how to merge it. And the super nice thing, well, I get super excited about it, so I can talk for hours, so don't worry, I'll stop. So, the super nice thing about this is that we can even do it across files, which is not, of course, something you do on a daily basis, but when you do it, it's really good. Like, you move a function to a different file because you're cleaning up code and you are refactoring stuff, and you just do that. While someone else was modifying the function on the original location, we can merge that. And diff it too, right? We can diff and merge that thing. And that's pretty amazing. I mean, I have this vision. My view is that sooner or later, all diffs and merge tools are going to do this. I don't know if it's going to be with our technology. I hope it is. But I think it's going to happen because there's no good reason not to do it this way. I mean, it's better than regular diffs on a daily basis, right? Of course, you can tell me, okay, you don't do that on all day. I mean, you don't do that every single day. Of course you don't. But when you do it, and it's more often than you think, it's super useful.
Wow. Sounds pretty cool.
Yeah, it does. One question I had was, since you're doing all this AST parsing and everything, is there any performance concern if you have like a multi-million line code base, or is it not doing enough parsing that doesn't become much of a concern?
Okay, suppose you parse you plug semantic to your Git, right? Which is something you can do. You can just say, okay, Git, use this tool as my merge tool. That's all. So you run Git merge tool and it runs semantic instead of, I don't know, KDF3 or whatever. Okay, when that happens, it will only parse the files in conflict. So if some files are not in conflict, then it won't be parsed at all because it's Git driving. I mean, if Git already knows how to solve it, then there's no worries in there. The second thing is about the multi-file. When the multi-file is in place, and that's something, well, we reuse some of the technology we have in Plastic SCN, which is our version control, plus semantic to create free. Well, it's free. It's still free. We don't know what is going to be commercial anytime soon. A free Git client, which is called gmaster. You can go to gmaster.io and download it, and it puts together parts of the two products. And this is the one doing the multi-file semantic merge. And when that happens, we have to interfere a little bit with Git in the sense that it's not the one actually driving the merge process, but we are the ones doing that because we can find conflicts in parts where Git doesn't. For instance, the typical thing of move code is you add a file, and then you have you have some code moved from the original file into this new one. When you merge that, Git is not going to find any conflict in the added file because it's new, right? There can't be a conflict in there. But we can find that there was code moved from the original file into the second one, and then we expand the scope of the conflict, let's say. So Git will say, okay, foo.c has a conflict, but we know that foo.c is involved in a refactor group with bar.c because of that. I have some, it's slightly more difficult to explain, just talking, right? But I have a few graphics that we can share later on a blog post where they can find a very neat explanation in just a few paragraphs, right, of how it works. So that's a little bit about it, right? It's all about the main motivation is, okay, let's make it simpler to actually find and solve conflicts. I mean, merges has been really feared by developers for, I don't know, I will say generations, but maybe it's a little bit too much, but that's many people's like, okay, I get a merge conflict. It's like, oh my God. And we just try to make it something much simpler and much more powerful. That's what it is.
So, you already mentioned that it works with Git. Does it work with any source control system?
Yeah, you can plug semantic into. It's just a standard diff and merge tool, because you can also use it to diff, right? It's not only merging, because in fact, you are going to use the diff part. We call it semantic diff, not very original, but you're going to use it much more often than you use actually the merge, because probably you merge, I don't know, a few times a week. Okay, depends on your role. Maybe some people are saying, okay, I do that on a daily basis. But anyway, you diff very often because you want to see your own changes, how you modify that. Okay, I'm on a good track, how I compare this to what other colleague did or something like that. And then you can also use the semantic diff in there, right? So yeah, it's something you use on a daily basis. And answering your question, yes, you can plug it to any version control system. In fact, you can add it, you can plug it to our own Plastic SCM. Of course, you can do it with Git. You can do it with Perforce. No reason not to do it with Subversion. So yeah, I mean, it's just, I mean, the same way you invoke KD3 or P4 merge or Araxis or Beyond Compare, you can just plug semantic in there.
What operating systems do you support?
Well, we have actually we're supporting Windows. We had version 1 on Windows, Mac, and Linux, but we have less demand, less interest, I would say, with Mac and Linux. So we delayed version 2. So we are more on the Windows side of things. Although, as I speak, I can tell you, because we are going to be sharing some screenshots this week about the upcoming versions for Mac and Linux. The thing is that the first version 1 of Semantic, was sort of alien in terms of UI, right? So it was able to actually solve all these semantic conflicts and so on, but it didn't look like any other three-way merge tool. Okay. So in version 2, we said, okay, let's simply add the semantic power to a more natural tool where you see the 3 panels with the 3 contributors and so on, and that's it, right? It's mostly like a regular tool just decorated with semantic information, and that's what version 2 is. But it's available on Windows only at this point.
Okay.
I wanted to interrupt the discussion for just a moment to bring you a word from our sponsors. PVS Studio Analyzer detects a wide range of bugs. This is possible thanks to the combination of various techniques such as data flow analysis, symbolic execution, method annotations, and pattern-based matching analysis. PVS Studio team invites listeners to get acquainted with the article Technologies Used in the PVS Studio Code Analyzer for Finding Bugs and Potential Vulnerabilities, a link to which will be given in the podcast description. The article describes the analyzer's internal design principles and reveals the magic that allows detecting some types of bugs. So you've mentioned it a couple times. Do you want to tell us a little bit more about Plastic SCM, this other source control that your company makes?
Okay. In fact, Plastic was the main motivation to start the company back in 2005. This is the main product we develop, or main source of revenue, I will say. And okay, we started it with intention to have something better than the availables, subversions of the world and CVS and source safes, as we said. And it was by the time when Git also started. So we started in 2005, and a few months after really starting the company, Git was out in its infancy. And well, we continue evolving through that, right? We have a very wide range of users, from indie teams doing, games with just 2-3 people, to some corporations with 3,000 developers using Plastic on a few projects, and we even have some super huge project with 1,000 developers in the same code base, which is kind of crazy in terms of merging and branching and all that. And we build it around a few key concepts, right? It's basically super strong with branching. It's very, very simple to do branching, super fast in Plastic. It's very good with merging. I mean, Git is super good with merging, but we can do even a few more cases and even making it a little bit easier than what they do, which is not easy because Git is good, but we try to be even better in that sense. So that's a real challenge. And then it's very good with big files and super big repos. Like we have customers with repositories in the 4 terabyte, 5 terabyte range, especially in video games. That's one of the things Exactly. That's one of the things we had to, we wanted to do by design from day one. And that's one of the things that separates us from other systems, Git in particular. Then we can also do something quite interesting, which is Plastic is fully distributed, but it can also be fully centralized and every combination in between. What I mean by that, you can work with local repos like you will do in Git, but you can create a new workspace, working copy, and work directly with a server like you will do in Subversion. What we mean by this is that in a lot of teams, you have really different profiles of people. So some of them are very comfortable with the distributed way of working, but some of them really prefer to go into the checking or commit mode directly to the central server, and that's it. Especially, in games, we are very big in games, and lots of artists, not super techie people that are not normally full-time developers, let's say, or just artists and stuff like that, they really prefer to just checking and done. And we also implement locking. Like, it's optional. We prefer merging. Merging is our life, as I said, so locking is kind of a, second thing to do. But there are certain assets, certain files that you cannot merge, and then locking is good with that, right? So these are sort of the key things. Of course, there's something I always forget to say, because it's mostly I take it for granted, but we develop the entire stack. It's not only the core, the server, the command line. We develop all the merge tools, as I said at the beginning, plus diff tools, plus GUIs in Mac, Linux, and Windows. Plus, it's sort of a complete package. You download it and you have all the pieces. It's not like, okay, I get the command line here, but then I need a GUI for some other provider, and then I need a cloud service from someone else. We just provide the whole thing, which is a lot of work, but it's fun, right?
You mentioned that you have very good support for large binary assets.
Yeah.
And then I started wondering, and I don't believe you addressed this, is it possible for your semantic diffing, semantic merge tool to work with binary files? Or do you have plans to say, like, well, these two PNGs were both changed by these two different people. Let's look at the actual images here.
Okay, one thing is a Plastic SCM version control, and it can handle really huge files. Release after release, and we do like 3 versions every week. Not that we deploy all of them to everyone, but it's like, okay, they are available to download. Each of them goes through a testing phase where we always check in a 1 gigabyte file, right? So size limit is not an issue, but that's one thing, actually, what the core can handle. And then you get the diff and merge. Can you merge a PNG file? No, with the standard diff and merge tools. You will need to have like a special diff or merge. We have a special diff for images. So you put 2 images together and then it can show you side by side. It can actually calculate the difference, which is sometimes is very nice, but some of it you don't understand anything because like kind of diff in pixels, so it's like crazy. But we can also do like a sliding image, like you put one over the other and then you have a slider and you move it and you reveal one side or the other. So if the images are completely different, then you don't really realize what's going on. But if it's the same, the same concept or the same image with a small modification, you can do it. So for diff, what we have is, we have diff for image, and then we have a way to plug custom diffs. For instance, like and again, it's not that we only work for games, of course, we work for a lot of industries too, but in games, they normally have like custom packages where they put like textures and 3D models together, packaged somehow. So many studios develop like their own diff thing, which takes one of these files, unpacks it, and shows you what was different. But answer your original question, no, we don't have a merge tool for PNGs or something like that. It's something that we've done something like that for Unity projects, for instance. We have our own merge tool based on the same core, but of course handling the actual content in a different way for what they call scene files, which are some text-based representation of stuff. But not for, we cannot do magic and merge an X files or something like that, right? No, that's not yet there.
Okay. I had another question, just thinking about all your tools here and your nice diffing and your source control system. And I was recently involved in a project where I was the person tasked with applying Clang format across the entire code base. And part of this resulted in a lot of white space diffs because we went from tabs to spaces.
Wow.
So basically, every single line in the entire repo changed. Now, I was able to resolve a lot of, potential conflicts by putting Git in, all kinds of ignore white space change mode.
Yes.
And I got something usable and then was able to pass off instructions to people who still had to do their own merging. And just out of curiosity, is this something that your tools would handle differently, or would we be in the same kind of...
That's one of the things where Semantic Merge will help, right? When you actually changing just the indentation or tabs by spaces, stuff like that, is not like a semantic issue at all, because, not a semantic merge at all, because the structure of the code doesn't really change.
Okay.
But it will help because basically it knows how to reduce it understands that the only thing that changed was a space or a tab or something like that, and it will react accordingly. In some languages, we even have the option, we have it for C#, have to check if we have it for C++ at this point, but we have a way that when it's going to merge a method, we have the option to reformat it before merging, which means...
Oh, okay.
If you are... if the thing is that suppose you simply split a line in 3 lines, like you have a call to a function, and you split in 3 lines to make it the line not that wide, right? To make it thinner or something like that. And then someone else added something in the middle or something like that. So you can have a really, a conflict in there. But if you reformat the code to a given standard or something, you can get rid of some of these reformatting things. And then you merge it and reformat again. That's something we provide for some of the languages. So sometimes you can solve some conflicts that were simply not able to be automatic, right? So that's one of the things we do. And for instance, some of the things, not exactly your case, but suppose the typical case where you add an include at the beginning of the file, and then 5 lines later you add someone else added the same include on a different branch. Semantic is smart enough. Not that it's, it's not AI or anything like that, right? But it's smart enough to actually know there's the same include added twice, so it will only keep 1. Automatically, we won't even ask you. Otherwise, you will get the 2. Okay, you add, stupid thing, but you add, I don't know, whatever, the same one, first line and then in line 10 of the file, because it's 10 lines of includes, right? Well, you just solve it automatically. And that's interesting, right? That's one of the things it does. There are a few others, for instance, it can warn you if there are conflicts in the same function, even if they don't collide. So you have an option to say, okay, warn me about that. Suppose you have a function with 10 lines. You modify something on line 1, I modify something on line 10. Any merge tool is going to merge that automatically because there's no conflict, it's not the same line. We have an option to say, okay, even if that is not in the same line, since it's in the same method or the same function, let me know, because maybe I want to take a look, because maybe I'm changing the logic in some way that I like to review manually or something. Okay, we can do this kind of stuff because you understand it's in the same context, in the same, it's in the same function. If you are not parsing functions, you don't know, you only know, when you work in text mode, it's the same to merge. It's the same for you to merge a love letter than a C++ file because you don't know what's in there, right? So basically.
Right.
Okay, now I'm totally going to be going out here on a limb here but I'm thinking about all the capabilities you've mentioned, and I would like a tool that if I go to make, there's a conflict go to make a merge, you said if 2 people edited the same function, you could warn on that. Is it possible with your semantic abilities to say, well, programmer A actually did a copy and paste of this code into another chunk, where really, that's some sort of smart copy paste detection on merge? That would be awesome.
We don't do it right now, but it's not the first time I am asked for this.
Okay, cool.
And it wouldn't be that difficult because, in fact, we're doing that when we diff the code. We are already matching similar text blocks, right? We already do that. In fact, before launching Semantic, we had something that we still have called xdiff and xmerge, and the X stands for cross or move, right? So we have move detection for test blocks, even if we don't parse the language. So Semantic can do that. Suppose you launch Semantic with a file you don't parse. I mean, I don't know, Rust. Okay, we don't have a parser for Rust. So you started with Rust. You move a block of code. Our system is able to figure out that this text block was moved because it knows it has a similar. If what you move is exactly the same, I mean, you just move to a different location, it's able to diff it and merge it correctly and apply exactly the same thing as I said with functions, but to test blocks. If you make small modifications after you move the block, it's still able to find it's the same up to a certain similarities. Percentage, right? So it's able to do that. So there's nothing preventing us to actually say, okay, it's the same thing up to some percentage or something, because it's something we do, right? I mean, it's already doing that. The diff is already using that for the calculation. The thing is that we are not providing the info per se, like, okay, saying, hey, you just copy the file or you just copy the method from this other place and you shouldn't be able to do that or anything, right? Okay.
Sounds really powerful.
Yeah.
Is there anything else you wanted to go over that we haven't brought up yet with either Plastic SCM or Semantic Merge?
Well, I think basically we covered all the essential concepts in here. The only thing I will say is that we have if anyone wants to give it a try, they can go to semanticmerge.com and they have a free trial for 30 days, so they just can download it and use it and see if it's really as good as I said, and check it for themselves. And if they want to use or take a glance of, get a better understanding of the entire technology we develop, including this multi-file semantic thing and so on, they can go to gmaster.io, and then they have a free Git client which comes with all the merge technology and so on. And of course, if they want to switch to a different version control, we have Plastic SCM, which is our main product and the thing that makes us, our hearts beat every day. So that's the big thing for us.
These are all, use the Git merge tool, Gmaster. Gmaster, you said, is free. The other ones are commercial. Do you have options for open source or students or that kind of thing?
Absolutely, and thank you for saying that because I always forget it. Yeah, it's free for open source. All of them are free for open source. And we have discounts for institutions, and we have free versions for individuals. So any individual can use it for free. No issues in there. Just have to, for in some of the sites, they can directly register and request the license and so on. Otherwise, they can always contact us. So for individuals, hobbyists, and stuff like that, open source projects is completely free. And then we have discounts for educational purposes and all that. So yeah.
Great.
We are pretty flexible in that, right? I mean, we are a very small team, very small company, and we are pretty friendly with all the licensing stuff. So, yeah.
Awesome. Well, it's been great having you on the show today, Pablo.
Thank you very much. Thank you very much for inviting me. It was a pleasure.
And Rob, if you may, before we leave, there is a news item we forgot to go over.
Oh, what's that?
The C++ on C call for volunteers and student submissions is currently up, and those are closing on January 1st, so that we'll get this news out just barely in time.
Okay, well, I'll put that link in the show notes as well. Okay, thanks again, Pablo.
Thanks.
Thank you.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/cppcast. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode was provided by podcastthemes.com. Site at cppcast.com. Theme music for this episode was provided by podcastthemes.com.